Welcome back to Module 7. We are still factoring trinomial expressions, but now we're going to combine two rules. We're going to combine the trinomial rule with the GCF rule. So this is important. When the directions say to factor, that means to rewrite the expression in multiplication. It means to break it down into all the terms as low as they can go. With factoring, it's sometimes not just a one rule process. It sometimes can be 2 or 3 rules combined. So that's why that checklist I gave you in the beginning is so important. When we factor a trinomial expression before we even start the trinomial rule, the first rule listed is GCF, which means if all 3 terms have something in common, we need to divide that out first to make our life easier. So if you look at my expression here in the PowerPoint, I have 6y squared plus 24y plus 18. It is obviously a trinomial. There are 3 terms, and yes, they are written in the correct descending order. But I am not going to do the trinomial rule first, because look at the leading coefficient. It is not a 1. It is a 6. So that changes up the game. All the trinomials we have factored so far have all started out with a 1 in front. 1x squared, 1y squared, 1a squared, 1b squared. Because if the coefficient's 1, that means there's only one option that goes first. Right now you have a 6 in front of that y squared. And there's not one option that multiplies to 6y squared. 6y squared can be 6y times 1y, or it could be 2y times 3y. And that changes the whole game. So everybody listen very carefully. I do not care that you automatically see that it's a trinomial and it has 3 terms. I get it. I get the expression has 3 terms. But the first rule of factoring is always GCF. If there's something in common with all the terms, you must pull it out first by doing division. So if you look at all 3 terms, 6y squared, 24y, and 18, don't you agree they all could be divided by 6? Isn't the 6 the GCF, the greatest common factor? So that's the rule I'm always going to do first. And when I pull out the 6, you put one set of parentheses to tell me what's left. So when we do the GCF rule, I should never see 2 sets of parentheses. So I pull out the 6 and I put in parentheses what's left. So 6y squared divided by 6 would be y squared. 24y divided by 6 would be the positive 4y. Positive 18 divided by 6 would be the positive 3. So that's the first step I did, is I looked at those 3 terms, I saw they had a 6 in common, I divided out my GCF as 6, and it left me with y squared plus 4y plus 3, which is still a what? It is still a trinomial. Now you can do the trinomial rule, because if you look closely, what's the coefficient now in front of y squared? It's a 1, and you're back to where I started you. Every trinomial you have factored always begins with a coefficient of 1, and that's your goal. Now that you have a 1y squared, you could put your 2 parentheses, say y squared is y times y. Then you can go to your last number 3 and say what multiplies to 3? Well, there's only one option, 1 and 3. Does it work? Well, let's see. I got to add to what's in the middle, which is 4. Will 1 and 3 add to 4? Yes. Because I said add, the signs have to be the same. Because I want to add to a positive 4, the 2 signs are both going to be positive. So this expression, factored completely, is 6, parentheses, y plus 3, parentheses, y plus 1. Do not forget the GCF that you pulled out in the beginning, which is 6. If you forget the 6, you're wrong. Because remember, you should be able to multiply this all out and get back to the original expression. So in the world of factoring polynomial expressions, don't assume you're just going to do one of these rules at a time. Sometimes embedded are 2 or 3. The first rule to always look for is GCF. Second thing, when you factor a trinomial, you want that leading coefficient to always be a 1. So again, if your trinomial doesn't start out with a 1, you need to be looking for a GCF. All right, let's hit the whiteboard and try some examples.